All right, last but not least, the fun part. We're going to deal with linear equations in three variables, x, y, and z. So if you think of x, y as the coordinate plane here, the z-axis is the one that kind of comes out, and so you're dealing with three-dimensional space. It's hard to draw in two dimensions, but one way you could think of it is like if we were in the classroom and you had the whiteboard and we drew the XY plane on the whiteboard, coming straight out of the whiteboard, sort of pointed at the class, would be the z-axis. Okay. So we are going to be solving systems of three linear equations in x, y, and z. And we're going to use elimination to do this. So let's read our instructions here, and then we'll work on one. So what you basically need to do is eliminate one of the variables twice. So you're going to pick any pair of equations and use the elimination method to eliminate one of the variables. Okay, so in this first example, I could take equation 1 and 2 and add them together because immediately the x would cancel. So that seems like a nice first step. Now, you have to pick another pair of equations and eliminate the same variable. This is key. Once you've done the first step, you have to eliminate the same variable again. So if I use 1 and 2 to eliminate it here, I need to use either 1 and 3 or 2 and 3 to eliminate x a second time. When you're done with that step, you will have a system of two equations and two variables. So you go back to everything we just learned and solve that system, substitute those values back in to find the third. So let's do it. We said we were going to use equation 1 and equation 2. I often label my steps in three equations and three variables because it's easier to track what I'm doing. So equation 1, like this would be 1, 2, and 3. X minus 2y plus 3z equals 9. And negative x plus 3y minus z equals negative 6. I'm going to add these together. First, I'm just going to double check that I wrote them right, because nothing is more annoying than going through all the work of doing this and then realize that you dropped a negative sign in the very first step. Okay, so if I add that together, I have 1y plus 2z equals 3. So now I've got to do it again. I need to get rid of x one more time, and I can't do the same thing because I'll just end up with the same thing. So maybe I'll use 2 and 3. And if I do that, then I'm going to need to multiply equation 2 by 2 to get the x's to cancel. So again, I'm just going to write that down here, 2 times equation 2, and I'm going to pair that with equation 3. So 2 times equation 2 would be negative 2x plus 6y minus 2z equals negative 12. I'm going to double check that calculation real fast because I don't want to make those silly mistakes. So multiplying by 2 would be negative 2, positive 6, negative 2, negative 12. All right, I'm in good shape. Then I'm just going to recopy equation 3 carefully. Two x minus 5y plus 5z is 17, and add them together. Okay, 1y plus 3z equals 5. So now, can you see how I have two equations with y and z? So my next step is going to be to take this system of two equations and two variables and solve them. So maybe I'll use substitution. I can see here that I have the y with a coefficient of 1. So if I subtract the 2z over, I can now take this expression and substitute it in for the y over here. I get 3 plus z is 5, so z must be 2. Substitute that back in for the y. So y is -1. All right, so I have two pieces of my ordered triple. I need to go all the way back to the beginning. One of the original equations, I'll just take the first one and plug in the y that I know. Y is -1, plug in, oh, see, I already did something wrong. It's x minus 2y plus 3z equals 9. It's so easy to make those kind of mistakes, and it's infuriating. So I'm always double checking because I literally can't add or subtract to save my life some days. All right, so I have x plus 8 equals 9, so x must be 1. And so my ordered triple would be 1x, y, z. And again, a quick plug in. 1 plus 2 is 3, plus 6 is 9. -1 minus 3 is -4, minus 2 is -6. 2 plus 5 is 7, plus 10 is 17. So I caught my arithmetic mistakes in time. All right. So one of the keys to this process is to stay organized. If you aren't organized, it can be a little tough to follow and know where you are. I think I have one more. Oh, yeah, it's on the next page. So again, I'm going to have you give this one a try. Let's all pick a particular variable. Let's eliminate y. You could do it with 1 and 2 and then 1 and 3. So go ahead and pause the video and then work on solving this system by eliminating the y twice. All right, let's check in and see how it went. So since we decided we would try to eliminate y, I started by multiplying equation 1 by 3 so that it would line up with equation 2 for the y's to cancel. I got 9x minus 7z equals 2. And then I went back to equation 1 and multiplied this by a 2, so it would line up to cancel the y's with equation 3. I got, it's in blue here, 5x minus z equals 4. So then, with these two equations, I decided to use elimination this time. So I multiplied this equation by -7 on both sides so that my z's would line up as opposites. So when I multiplied it by -7, that's over here, just pulled this one down, canceled the z's, and solved for x. Plug that x back into this equation to find my z. And then last but not least, whoops, wrong button. I took equation 1 here and I substituted in the x and the z that I had found in order to solve for y, and I got my y. 1, -1, 1. I did double check those, and they all worked out in all three equations. So solving system of equations with 3 variables is a little bit more work, but you do need to double check your calculations each time you do one, just to make sure you're not doing something silly that's going to screw up the rest of the problem.